Okay, welcome everybody. Tonight is the 13th of July, 2021. This is Dallas Personal Robotics Group Robot Builders Night Virtual. We're going to do our usual thing and walk around the table, whoever's online, and chit-chat mainly about robots or old age or whatever strikes our fancy, how to make it successfully through old age. Who knows? All kinds of topics come up. So if you're new to the group, please realize we do record these. So if you don't want to be in the recording, just don't say anything. Otherwise, the tool will take your focus and record you for our YouTube channel. So with that, I'd like to pass things along. I think Chris from Connecticut, welcome. And it sounds like you've got some something to talk about.
Yeah, not a whole lot, but I'll kick it off. So first, two topics. One is Romy, my platform. The other is a little bit more open-ended, and well, hope I don't go down some rabbit hole. But so on my Romy, not a ton of progress really to talk about. I've been just rearranging a few things, really trying to avoid adding a third deck to this sandwich. Although I guess it would be very useful, but so what I've been doing, I've been putting more stuff in the bottom, in particular the B&O 85 is now in the bottom. You know, I already had the Cutie Pie in the bottom, my I/O slave controlling my line sensor array. So what I decided to do, I had this B&O 85 until recently connected to a separate black pill type of device, but I didn't really need all the extra I/O that device gave me. You know, just for collecting data from the B&O, it seemed like overkill. So what I've done is I connected the B&O I2C to the Cutie Pie. You know, it's a Cutie Pie is a Cortex M0 Plus. It's got enough horsepower to do, you know, whatever it's got to do for the analog array and the talking to the B&O. And so all that goes back over my USB serial link. So just you know, making the Cutie Pie here do a little bit more work because it had the I2C available and had one pin available that I'm using to reset the B&O, which I find I have to do just to make sure I get everything to initialize properly. So that's again just shuffling things around, trying to make best use of the limited space here. Haven't done much with the LiDAR yet. I did realize, I know I mentioned I can run this thing at 20 hertz and not have any vibration. I mean, that's not entirely true. So at full speed, this thing does transfer some amount of vibration into the platform. So I'm just gonna have to do something simple. I haven't really tried anything yet, but I was just thinking some thin layer of, you know, foam. This is probably too thick. Some thin layer of foam on the bottom. And then I haven't even properly secured it yet to my Romy. But, you know, then I was thinking I gotta have some foam so that it can't sort of, something that absorbs the vibrations going side to side, right? And something that absorbs the vibration, you know, in this direction. Again, this is not my forte at all, this mechanical stuff. So I'm just gonna fiddle with that a little bit. And it's not a ton of vibration that I need to absorb, just enough so it's annoying, and I'm a little worried how that's going to affect the B&O. And I watched the YouTube video from Saturday. I know, Carl, you mentioned in your experience, you had some issues. I think it was you who mentioned there's some issues that you think were vibration related, where the B&O wasn't giving you the results you wanted. So
Yeah.
So I may have seen that comment also elsewhere. So that has me a little worried about even kind of small amounts of vibration that are, I mean, it's small, but it is noticeable, you know, kind of messing with my IMU too much. And so that's why I think I need a little bit of vibration isolation here.
I have some interesting thoughts on that if you want to.
Yeah, so let's pause there. So let me just wrap up my thoughts here, and then let me hear that. I would definitely want to know. So that's on the Romy platform. I mentioned that I've added some fans the other day that keep the Pi 4 nice and cool. Taking the batteries out down here now that I have, you know, more and more stuff going on, is it's not a big deal, but it's annoying. So what I started to do is, if this cable is long enough. What I started to do, I started charging the batteries while they are installed in the Romy. I mean, not a big deal really, but what I bought some time ago, I don't think I showed this. Again, you guys must have this already. It's a $15 grade constant current power supply. So it's you know not very user friendly because you got to adjust the voltage and the current limit with these real small screwdrivers, right? It's got just a multi-turn precision pot, right, for adjusting the voltage and the current. So that makes it a little cumbersome, but it's pretty good. I mean, it's you set your voltage, it's step down, so I'm feeding it with an old laptop supply, 20 volts or so, right? And it'll happily put out up to 15 volts. I don't remember the exact specs, but it's like a 60-watt device, and it's very small. And so I set it to 8.5 volts or so, or something a little above 8.4, which a full set of 6 nickel metal hydrides, there you go, would be. And I set it to a current limit, and then I have it plugged in. I can use it for charging, or even I have it plugged in when I'm sort of sitting on the bench, right, and running. So it'll supply power to the Pi and everything else, and maybe there's enough juice left over to charge the batteries if necessary. But I usually have it set to a current limit of 1 amp. And I usually don't reach the current limit anyway. So so that's convenience. I don't have to take the batteries out, because previously what I ended up doing to conserve battery power to some extent, I was running a 5-volt USB C supply cable into the Pi 4, right, just to have the Pi powered, and then the Romy electronics would consume battery power when I'm on the bench. But still, that wears out the batteries. In this way, I just go straight into the Romy sort of connector there, the pins that are available that expose the battery terminals, and so I can charge. I can, just keep things running without consuming battery power. So it's just a little convenience thing. But yeah, these things, again, there's probably more of these little gadgets that I don't know why I never bought them, but just like these little transistor, resistor, capacitor testers with little LCD screens, right? I mean, these things, as they're cheap as they are, I mean, quite handy. So,
yeah.
I think that's on the Romy. But then I just wanted to put one question out there. Again, we don't have to necessarily discuss that because it's a little open-ended potentially. But on the subject of subsumption, again, one thing, maybe it's a question for David Anderson, really. And let's see, which screen are you seeing? Okay, you're seeing that. Okay.
I'm sorry, Chris, I just stepped away for a moment. I missed what you said.
Okay, I just started saying, okay, I'm just, apart from my Romy update, I wanted to just put a few things out there on subsumption and maybe ask a question to you. And we're going to pull up a diagram here while I do that, because one thing, going back to when I read those original papers, when I was in college, and the original subsumption talks about subsumption and inhibition. Now, we've been talking a lot about arbitration, and that all makes a lot of sense. But if you look at some of the subsumption diagrams that are out there in some of the original papers, and I couldn't dig up the original paper, but if I just, let me see if I can just put one up there. Honestly, I could, there's the diagram I'm looking for. Okay. Yeah, I could never, that's just part of my question, really. I could never really figure out what this inhibition was all about. I should really say suppression. I'm confused sometimes, right? So this whole notion of suppressing the inputs, in what we have been talking about, and Dave, what you've been talking about, right? This notion of suppressing inputs, I don't think shows up anywhere. the notion of arbitration, the way we've been talking about it and the way you've done it, Dave, right, is really more analogous to what Brooks calls sort of inhibition of some outputs. Although I'm not sure it's an exact one-to-one mapping. And yeah, I know some of these, okay, here where it gets, some of the diagrams that you have shown, and they make a lot of sense to me with the arbitration, right, are very clean, versus if you look at some of those original diagrams from Brooks, when he combines his notion of inhibition and subsumption, it gets pretty messy. I could never figure out exactly what the heck was going on, back then when I read those papers. And so I just was curious, Dave, if you had any thoughts on that, or if there's some other book I didn't read, or not every page. So what happened to this original concept of subsumption? How did we get from there to where we are now with this arbitration? Was that just some evolution, or did someone else, sort of improve upon Brooks's original work? Or that's why I just wanted to know what your thoughts are. If you can, can shed some light on that, if you know.
I would basically agree with your last statement. If you go back and look at Brooks' original papers, he includes a whole lot of features that were not promulgated to later functions. In particular, among those are suppression and inhibition. I actually, in my robots, I include the ability to suppress. The arbitrator does that. Basically, there's a set of flags that tell you whether or not a particular function is enabled. And there's another set of flags that tell you whether or not that function wants to control the robot. And there's another set of flags that say whether or not those functions are suppressed. The only place I use that is when you're, for example, honing in on a cone. You can suppress the avoidance behaviors so they don't push you away from the cone as you're trying. But I would say that basically what I have found a whole lot more useful than Brooks' original papers were the papers and the books written by Joseph Jones. Are you familiar with any of those?
Yes, I have the book, but that's what I said. I probably haven't. Well, I haven't read it in a while, that's for sure. I don't remember when I got it, but I probably need to go back and read that. Yeah, that's what I thought. There's something in there where he simplified the whole thing, and then that's what.
Yes, and they're much simpler, and they look a whole lot more like my drawings because that's basically where I learned it from.
Okay.
There was an original set. Jones and what's her name, Flynn, wrote that book, Mobile Robotics. Right. There are two versions of that book. The second version was done without his permission, and he suggests you don't buy it. But if you can buy the original version, it's blue. The second version is red.
Yeah,
Look for the blue.
I have both, but I probably need to go back and study some of that material because it's been a while. So.
Well, the second book he wrote, I believe, is entitled Behavioral Robotics, and that's basically the way I do things. So you have a whole bunch of tasks, and they're arranged in a hierarchy, and they all do calculations and do an output, and a flag that says whether or not they want to control the robot, and the arbitrator simply picks the one with the highest priority and passes its behavior along. I'm with you. I go through those Jones papers, and I mean those Brooks papers, and I just go, what the heck is going on here? There's just way too much. Yeah. The whole inhibition thing basically was dropped after his first papers, and even the suppression, which, as I say, that I use that, but you're kind of cheating the subsumption paradigm when you do that, because you're allowing lower priority behaviors to turn off higher priority behaviors. Well, what does priority mean if a lower priority?
Exactly.
Yeah.
Yeah, it's pretty messy.
I think you have to do that very cautiously, and there are some ways. I would use the term out of band signaling, and I'll give you an example. When in the talk I did last month, I was trying to illustrate how wall following works. Okay, so you have a very low priority behavior that is, trying to turn you toward the wall, and you have higher priority behaviors that are trying to turn you away from the wall. So what happens when you get a common detection? When you're wall following, say the sonar or the IR gets a common detection, When you're not wall following, we use that clever keep turning the way you're already turning. But when you are wall following, you always want to turn away from the wall. You never want to turn toward it, because that'll send you backwards in the opposite direction. So that's where the out of band signaling happens. The sonar and the IR behavior actually can monitor the state of this low level wall following behavior. And when they see, oh, we're wall following on the left, that means common detections always turn me to the right. So there are, and I refer to that as out of band signaling, because you're basically passing information between the behaviors, which in purist subsumption, you're not allowed to do. I'm not a purist. I'm more pragmatic than that.
Yeah.
So there are some functions like that, but for the things I have done, I have not really found the inhibition and suppression things. There are easier ways to do the same thing that don't make those drawings incomprehensible, which is that I'm totally on board with you the same way in terms of those functions. And as I say, I would say that the forms of subsumption I use are the forms that were promulgated by Joseph Jones, a disciple of Brooks, but not the Brooks models themselves. Was that your question?
That is my question. That answers it. And my takeaways. Yeah, I gotta go back and read some things that I probably read 10 years ago and don't remember the details of. So that's I think what I gotta do, because I really want which is, it's kind of weird, because again I those papers are what got me all started originally, sort of on this path in college. And what's strange is I've never actually implemented a robot using kind of anything that resembles behavior-based an approach, whether similar to Brooks or some derivative. It's because my only functioning, or let's say fully finished, I should say, robot to date has been one or two versions of my firefighting robot, designed specifically for that particular competition. And yeah, if I look very hard, I could argue I may have used some elements there, but the approach I took there wasn't, I can't really argue it was behavior based, because it had a very specific mission. And honestly, I always struggled with figuring out how to use that behavior based approach to efficiently carry out a very specific task, right, in a very much known environment. So I actually felt for that competition, an approach where the behavior just emerges out of the combination of the behaviors is not the most efficient approach. So that's why I haven't used it. But I've always been wanting to sort of try that, and wanted to see what fun, things would the thing do if it just let the actual behavior emerge from more lower level behavior. So I've never actually done that, which is kind of, again, in a way, surprising for as long as I have been doing this, sort of on and off, really, continuously. But so that's why I'm asking the question, because I want to try that at least once and see,
Well, in that sense, the term behavior based is probably more accurate, because subsumption covers so many sins. And Jones, if you look at the behavior-based book, he introduces some pretty interesting ideas. One of the things he does is his arbitrator saves whoever won the previous round of arbitration. So the task itself can find out whether or not it won, which is kind of useful for certain things that you can't do in the Brooks paradigm.
Yeah. So I need to try that. Again, because that competition setup, I felt like, if you want to complete the task in a environment that's kind of 80, almost 90% structured and known, right? I felt like taking that approach might actually be suboptimal compared to the human me pre-planning the steps a little bit more with state machines and the combination of wall following. And okay, now you're here. Now switch to wall following. Okay, we must have reached here. Now switch into this other mode, right? Kind of more pre-planning versus letting things just emerge. So, but like I said, I want to try it out in an unstructured environment that's sure to be more robust than something I can pull, than me coming up with all the corner cases. Something that's more behavior based is presumably a bit more robust. I guess that's the hypothesis.
I think that's right. I wish Paul Boucher was here. Paul, I think the only time he's been here recently was for my talk last month. But Paul knows a hell of a lot about this, and he worked for the military, designing robots and robot systems. And he and I have talked quite a bit offline about it. And one of the things, he was very complimentary about my talk because he said it was simple. And the things he's worked with, he said they get so complex that they're not controllable anymore. And but his observation was that it's exactly as you said. If you had a function like you want to write a firefighting robot, and that's all it's going to ever be, then you really don't need to worry about getting caught up in this system where as things get larger and larger, they get uglier and uglier until they're not controllable anymore. But if you want to have a more general purpose robot that can do lots of different things, then you need to be more disciplined about the way the ideas grow and the way the functions are added on and so forth. As I say, we need to cajole Paul into joining these groups because he's really a valuable resource. He knows a lot about this.
Is it my place to be controversial here?
Sure,
Nope.
always.
Well,
wait.
I'm going to do a demo today, and I actually just realized over the last few weeks in the conversations we've had that I'm actually on the opposite side of this, that I have actually implemented Brooks design with suppression and what I'm calling suppress and release. So each of the behaviors as a Python class has an enable disable flag, but it also has a suppress and release flag. And I can demonstrate that it works. And I actually found that I've got an arbitrator class, but I'm actually not using it. I didn't realize that. I was sending signals to it, but I've actually accidentally designed around it. And there's no, all of the behaviors are events in an enumerated class that has priority. And so there's never a place where a lower priority event or behavior can overrule one that's a higher priority. And I can demonstrate that. So for example, I've got both a roam behavior and an avoid behavior, and the avoid behavior is higher priority. So, and like I said, I will demonstrate this. I don't have a robot, but I've got the OS now running. And so if I, let's say, for example, send the robot forward and then turn on the enable the avoid behavior, because it's all the behaviors are default disabled. So I turn on the avoid behavior. And then if I hit a key on my keyboard that simulates a bumper, the avoid behavior will be released. No, sorry, it's already unsuppressed. It will then back the robot up and turn and do an avoid behavior. If during that time I hit any of the other behaviors that are lower priority, they will not override that. But let's say, for example, the roam behavior is running, and all of a sudden while doing that, I've also got the avoid behavior enabled. If during that roam behavior, something triggers the avoid, it will overrule the roam behavior. And so I am actually on the other side of this thing. I look back, I have read the Brooks papers and I have read the Jones book, and I realized that in this kind of dichotomy between the two models, I've kind of hewed towards the Brooks model, not because I deliberately, it's sort of how I ended up. And it seems to work. I can create a behavior class, which is actually, and this is an asynchronous publish and subscribe model. So it's a bit different. It doesn't really even need to operate on a 20 hertz loop. It can actually operates effectively as interrupts because they're just events being sent by the sensors. And anytime that triggers a message onto the message bus, the subscribers pick those up, and behaviors can be both subscribers and publishers. So if they only take information in, they'll be a subscriber, but if they need to basically publish, let's say, something to a motor controller, they'll also be a publisher. And so, for example, with the avoid, it's looking for an avoid signal that turns it on or off, but it also is looking for a bumper press or an infrared, and any infrared within a certain threshold of distance, or any bumper which has a 0 distance, triggers that avoid, and then it'll go into its ballistic mode, and it can only be overridden and aborted basically by a higher priority behavior. So that's kind of what I've done. And
but isn't that just standard arbitration? I mean, guess
There's no arbitrator in that at all. It's all message. It's a, like I said, it's a publish and subscribe message bus, asynchronous.
well, I
And-
mean, okay, so that's how it's implemented, and we're talking about conceptually. What you just described still sounds like one behavior over. I mean,
Yep. That's what I was
overrides,
trying to
call it
describe
whatever
last
you
week.
want. You know, there's arbitration taking place in the priority scheme. Again, when I refer to the original Brooks paper, again, there were two things going on. One's called inhibition, which takes place on the output side of a behavior, and then suppression. I mean, I'm looking at the diagram here just to make sure I get that right. Yeah, the suppression takes place on the input side of a behavior, and that's the part that, you know, I don't know what that's doing there. Why does one behavior have to make the input to another behavior go away? That's to me the difference, right? I mean, whether you call the output arbitration thing or overriding thing, or, you know, it doesn't really matter what you call it. Different things are producing an output. You can only act on one of them, right? Somehow you decide which you know, motor command you act on. But are you saying you're also doing something on the input side where one behavior changes the input to another behavior?
I guess what the thing is that we can sort of argue about implementation details, which I don't think either one of us wants to do. I think that what David has done and what I believe I've done is a subsumption architecture. They're just implemented differently, very differently. And I think that kind of earlier Brooks idea of suppression and you know, like inhibition or whatever we want to call it.
Yeah, there's both. There's two different things.
Yeah, but it doesn't. That's an implementation detail. The point is that you have behaviors, and some are higher priority than others, and you don't want a lower priority behavior to override a higher priority behavior, and you also want the ability to inhibit another behavior. So, for example, like David's talked about a line follower, that as you get close, you don't want the robot to take on a lower priority behavior that would push it away from the wall if you're trying to get to a wall or if you're trying to dock or something. So long as you allow, and this is now talking about my model, so any of my behaviors, let's say a docking behavior, I don't want to have a lower priority behavior that says you can't get close to anything to be higher priority than a docking behavior. The dock says, look, forget about bumping and infrared, you're gonna bump. And so it would then have the ability to send a message onto the message bus saying inhibit bumping and to anybody who's paying attention to that. And the other behaviors would basically not have a priority that could override the docking behavior with regards to the certain messages that would be sent by the bumpers and infrareds. And that's kind of the model that Brooks has, as far as I can read it. And I've implemented it such that with each behavior being able to both subscribe to events or messages and publish back other messages that other behaviors can read or subscribe to, that's kind of got everything that Brooks talks about, I believe.
Yeah, interesting.
And so I can demo that now or later. It doesn't really matter to me, but since we've been talking about it, I'll go ahead and swap the screen over. I need to share a screen. I always have trouble remembering how to do this.
After that, maybe I can jump in and talk about the.
I was just going to say, Carl, I do want to hear what you have to say about
Yeah,
vibration and the IMU. So
I've got some things to say, and I think Ray has something to say.
I'll do mine later then.
Well, if you're ready,
Well, I've got a screen ready. I mean, I can do it later.
pop it up.
Go ahead.
If there's other topics that are in front of this one in the queue, that's fine.
Well, we're on subsumption. Let's wrap it up.
Okay. All right.
I was just saying, I was hoping to get dibs after you're done with yours.
I'm not seeing that. Oh, here, hold that one. No. There. Okay. The Mac is not showing the screen that I want for some reason.
While Murray's bringing that up, I'd just like to observe that suppression being in the input means don't do it. Don't waste the time computing because you're suppressed. Inhibition on the output means ignore the output because I don't care about you, my opinion.
I'm not disagreeing, Doug. I think, but that's what I was saying is that kind of gets into what you'd call an implementation detail, because depending on how you implement the subsumption architecture, the message passing and how things interact with each other component-wise will be very different. And so in my case, I've got Python classes, and they're implemented as either publishers or subscribers or both as behaviors. So my keyboard, for example, I've got a publisher that publishes key presses as messages. So I can hit stop or go for full forward or whatever. And then I've got publisher, I should say, subscribers that are subscriber only. And then I've also got these, I hate to say higher level, but they're behaviors that multiply inherit both publish and subscribe behaviors. Sorry, I'm using the wrong terminology. They're multiply inheriting both the publish and subscribe classes as a behavior, so they can both receive messages and publish messages back. And in doing so, if they can receive messages off the message bus and also publish messages onto the message bus, they can therefore receive messages from other behaviors as well as publish messages onto the message bus that other behaviors can listen to. And because everything is prioritized, if I write a behavior correctly, I can have it automatically ignore things that are below the priority, or pay attention to and maybe abort or postpone a behavior if they receive a message from a higher priority behavior.
Right. So that means that you're doing both of those correctly. I only brought up what I said because Chris was saying he didn't quite understand why you would have both of those things. And that's why I was saying that suppression means don't bother even wasting the CPU cycles. Yeah. Whereas submission says, I don't care what you're saying, I'm going to ignore you.
Yeah, again, I don't remember those original papers, but I think suppression, there's more to it, because if a behavior has multiple inputs, you might suppress just one of the inputs. It's almost like you're trying to alter how the behavior behaves by taking one of the inputs away or overriding it with another signal. Again, I would have to go back and read those papers. It's just, again, never been really clear to me how this...
Well, Chris, I think your observation, your initial observation is correct, which is that both inhibition and suppression are peripheral to arbitration. That is to say, I think Murray mentioned earlier, he said those are just different ways of implementing subsumption, but that's not the case at all. They're basically add-ons to the basic function of subsumption. And it turns out when you get further into this, that this is kind of like, when you start using go-tos in your source code. Yeah, you can make it work that way, but the more that you do, the harder it becomes to debug, and the harder it is to predict how it's going to behave. And as those ideas have been further developed, both of those have been dropped by the wayside.
I'm sad to be on the wrong side of evolution then.
Once again,
can you see my screen now?
Yes.
Yeah.
Okay.
And if it works for you, that's good.
All right, so here we go. Now, I can't see what you guys see. I can just see the screen now. So this is the help screen. So you can see all the different keys that I can press to basically fire events onto the message bus. So I just hit an I, and that basically prints information now. So you can see that I've got 3 publishers: an event publisher, which is my keyboard. I've got an avoid and an idle. That the idle one is a behavior that is very low priority, that just basically triggers the roam behavior after about 20 seconds. I've got 9 subscribers, which again, idle. Sniff and moth, I haven't really done anything. They're just sitting there. They don't do anything at all. And then roam and avoid are also subscribers. And then there's a behavior manager, a garbage collector, a bumper subscriber, and a motor subscriber. And the motor one is the one that actually currently is mocked, but if this is running on a Pi that has the motor controller, it would therefore control the motors. So we're not doing anything. You can see that it says movement stopped in the bottom right there. So we could basically look back at here and say, okay, if I want to go full ahead, that's a 9. So I do that. So now we will run up to 90, which is full ahead. So now we're running at full speed. And now I'll hit M, which is going to turn on basically enable. You can see that it now says that we've released the avoid behavior. It's now enabled. It's not running, but it's enabled. And we're now running at 90. Now, if I hit J on the keyboard, that'll basically do a bumper press. And you can watch now, as I do this, this is basically what we would normally call a ballistic behavior. It's now turning from straight ahead to straight astern for a certain amount of time, turning ahead to starboard, turning ahead to starboard, now back to straight ahead. Once it's done it, now we're going straight ahead, and now we're back to movement again. Now, if I hit, let's say I can go change, and now we're going kind of turning ahead to port because I hit slow down the port motor. And I can even that out with another message. Now we'll be going straight ahead. And if I hit, let's see, I've forgotten it. If I want to brake, it's a minus, and that will slow us from full speed or whatever speed we're going and slew down to 0. There, and now we're stopped. And I'll stop sharing my screen because that's really all I was trying to demo.
So does this run on the real robot at this point?
That's actually running on a Raspberry Pi, yeah. It doesn't have the motors connected because I'm locking the motor controller, but that would, if it was connected to the Pi, be running the motors, yes. And if it was connected to the my integrated front sensor thing, the bumpers and the infrared sensors would be sending actual messages rather than me hitting key presses on the keyboard. So that's actually the OS running.
Cool.
Nice. It's pretty cool. Yeah,
Well,
that's a good demo.
How many lines of Python code? How many lines?
It's a whole bunch. Well, it's not. It's a bunch of. It sounds like a criticism, Chris. It actually runs.
3 lines and 10 libraries.
No, actually, I can tell you, L core. The essentials are the message bus, a logger. I'm not actually using the controller anymore or the arbitrator. I've got a YAML configuration scanner. I've got an OS. It reads a YAML configuration file, fires the thing up. It's got, if you type on the command line, you get help and everything. It does actually run as a systemd process. So when you first turn the robot on, it'll actually fire this thing up. It's got a subscriber, a publisher class. It's maybe about 7 or 8 main classes. And then in the behaviors, it's as many behavior classes as I've got. So I've got an avoid and a roam right now that are doing something, and a behavior manager. So it's somewhere around 12 to 15 classes in Python.
Okay, so action item for next meeting. I want to know how many lines of code. Just out of curiosity.
You can go up and look. It's on GitHub.
It's not a criticism. Clearly, a lot of work went into this. Clearly, a lot of work.
Yeah, sure. I'm not denying that. I'm trying to build out what I think of as an asynchronous message bus based version of what Brooks did.
Yeah. So the only reason I kind of going down this path, right, with this comment is, well, you sure you're not going to end up with just what they call a ROS, right? That's my only question, right? Because I know you want something that's not too simple, and I know you don't want the full complexity of ROS. I think you want something in the middle, right? At least that's what I'm kind of assuming. But just you sure your trajectory is not pointing all the way to the full, ROS.
Well, I took all these dozens and dozens and dozens of classes that I'd written, over the last few years, and pulled out of that what I'm calling my K-ROS, my K-series robot ROS, CROS. And that's what is now a separate project on GitHub, and that's what you just saw running. And that's, if I stripped out the stuff that isn't necessary, because like my test classes and things like that, like I said, there's a YAML configuration file thing, which maybe isn't necessary, but all of those subscribers and publishers, everything effectively is a subclass of a finite state machine. So everything in its function runs as a finite state machine. So all of those classes together, I've now got the ability to handle bumpers and infrared and a motor controller. And so it's effectively a finished project once I get this actually hooked up to the motor controllers and the actual sensors. And right now it's all mocked, but I don't need the video camera features that I had and all that. So it's done in that sense, in terms of size. I don't need to implement a lot more. I just need to finish this. And like the behaviors don't work time-wise. For example, I've got a bug that if it's going full speed forward and you say go full speed backwards, it actually jumps to 0 and then slews down. So I've got bugs and things. But in terms of the size of the project, Chris, it's not going to get much bigger than this.
Okay.
2 things, Murray. One of my newest and most active followers on Twitch and my Discord, his name is Jim. I believe he's on there. He gave you a compliment today and said that new NZ robot guy does awesome documentation and all that kind of stuff. Okay. Compliments. I wanted to pass that along. And the second thing is, I kind of had to step away talking to the wife, and I came in on a little bit of this discussion here. So can we get back to talking about effective use of go-tos in modern software architecture?
No.
Can we put that after PID loops and ballistic discussion?
Yeah.
I want to hear Carl first before he gets up and leaves.
I prefer the come from.
Because the go-tos, oh my goodness. Let's go to that after this next thing. How about that, Harold? That could be a fun discussion. Okay.
Well, impressive piece of software, Murray. I mean, that's for sure. Again, I even though I poke at the need for the complexity at times, it's, you know, at the end of the day, it's impressive piece of software.
Well, thank you.
Well organized and presents well in the console flow there. So
Yeah.
Well, it's funny because I write it on the train as well as at home. And so I wanted it to be able to run on a laptop. And the whole idea of having keyboard presses rather than, otherwise, where's this thing? Oh, here. I don't want to have to carry this on the train. I mean, there's no way. And so the idea, it's kind of turned into a simulator. In theory, I could write a visualization of the robot's movements and turn this into a simulator, though I'd have very little interest in that. But it does run on a laptop. I mean, I run it on a MacBook. And when it's on a Pi, it senses that it's on a Pi, and it can get access to the Pi's temperature and things like that. So that little information display out when you hit I gives you the amount of memory available, the current temperature of the Pi, how many, because there's messages, so there's a garbage collector, and you can see how many messages are still sitting in various queues and all that. There is a lot of complexity there that maybe isn't necessary, but I can't, David and I may be poking at each other, but David knows that I have a huge amount of respect for what he's done, and I'm just doing something very different. And it's only been this last few weeks of discussions that and particularly today, in realizing that that the whole Brooks architecture, if you want to call it that, is kind of where I was more heading towards than the Jones one. And I didn't quite realize that until I realized in the last 3 or 4 days that I actually wasn't using an arbitrator class. I'm sending messages to it, but I don't really even need it. The arbitration happens between the priorities of these events. And I've just taken a very different approach to this, I think. And I think we talked about ballistic behaviors and all those things, and they are, I don't want to make it sound trivial because it's not, but they're kind of implementation details, and we can get lost in that. Because the overall gist of this is we're trying to create a subsumption architecture. And the idea of subsumption says there's various priorities, and that a higher priority can't be overruled by a lower priority. And past that, it's all kind of implementation details. Because if you can do that, you have a subsumption architecture. And so we'll see if this thing runs well on a Pi. As far as I can tell, it seems to. And I've obviously have been poked at as encouraged me to try to make it work. That's the nature of things. If you get poked at, you want to prove that you weren't wrong. So
it's going to work.
Effectively, that's what I've been doing. So.
Yep.
Good stuff.
Enough said.
Okay.
Thank
So
you.
Chris, can
Yes.
you restate, just frame up then the question, and then I'll dig in.
Right. So what I realized is that when this is running at 20 hertz, it does transfer a noticeable amount of vibration into the platform. And so what I've seen now in multiple places is people talk about interaction of, small vibration of the robot base with the IMU, which I have mounted now on the bottom. And so that's why I think now I need the vibration doesn't bother me, but I'm a little worried about that interaction now that multiple people have mentioned it. I haven't measured it yet, I have to say. I haven't done any tests to sort of see if there's a noticeable difference with the LiDAR spinning at 20 hertz versus LiDAR not spinning. But again, the reading about vibration in IMU together not good, has me worried and has me thinking about how do I reduce the amount of vibration that transfers over. So yeah, I'm gonna need sponge steel, little pieces of foam, whatnot. I'm gonna have to tinker around a little bit.
Well, here's the two. There's the two thoughts that I'd share with you on this, because I think you mentioned the BNO 085.
Yeah.
And the one that I mentioned on Saturday at the Robothon was the BNO 055.
Right.
Okay, so the two thoughts that I have, there's two dimensions I would put out there as potential culprits, concerns. One is mechanical, and one is actually firmware in the IMU itself. So when Murray puts up the seal and when Ray puts up the vibration isolation dampers, they're talking about the mechanical path. So let me show you something about that, give you some perspective on that from my view first. So my experience on the mechanical interaction from vibration into an IMU actually came on this vehicle. This is a light armored vehicle, air defense. And in my first job out of college, actually the third work assignment, major work assignment, I did some electronics that are inside of this vehicle. So it went to the field in '99 after I left TI, and then it got retired, I think, in the last few years or so. But if you'll notice, there's people that sit behind these windows, and these are, I think these are Stingers that they can shoot. So this is not a small vehicle. And inside behind this thing, there's a couple different, there's like a day filtered piece of glass and an IR filtered piece of glass. And behind that is a really stiff mirror on a 2-axis gimbal. And then what the mirror does is reflect the optical energy down to sensors. So there's a turret that sits underneath. There's a turret in the turret. So there's a turret underneath those mirrors. All the sensors aim upwards. They bounce off the mirrors and look forward. Okay. So my job on this system was the lead EE guy on the Periscope head mirror. Okay. So it had basically this really is 20-inch by 1 foot kind of really stiff diamond turned metal mirror. And it had a gyroscope that would sense the orientation. I guess it was a rate gyro, I guess, but I didn't do the control system on it. But anyhow, it would sense the orientation of the vehicle, and then that would feed in the electronics. The control systems guys had the algorithm running, and that would control the mirror so that, even if this thing is firing down, if it's driving down a rocky road, if this Gatling gun it's aiming off to the side, the Gatling gun is shooting, so the thing is recoiling off to the side. It's bouncing off the rocks in the road. There's a lot of vibration going on. So at my last year and a half at TI, basically, a huge amount of that time was going down to the room that had this giant vibration table. So we would put our head mirror on this vibration table, and that thing, it had the power spectral density that represented the mechanical vibration across like many hertz at that point in the vehicle when the vehicle was doing different things out in the field. Okay. So we spent, and the trouble is that the system wasn't stabilizing as tightly as it should. So it would drift. You'd get to these certain power spectral densities on the vibe table. It would shake the thing, and it would just walk across. And I don't know how many months we spent running down and trying that out before they finally brought in this really smart retired systems engineer. And he started looking at the construction of the gyroscope itself. Okay. And the gyroscope was a kind of a novel thing. And it had this piezoelectric element that would sense motion. And what he figured out, and they later proved after I left, apparently, by changing out the gyro, but the no matter what kind of vibration isolation they had, some of the energy through this giant metal chassis was ringing through and coupling into that piezo, and the piezo was acting like a diode. It was detecting that energy and throwing offsets into the feedback loop, which threw offsets into the mirror, so the image would walk along the scene. So that whole thing leads to then, well, if you know the power spectral density, so how much energy is at 1 hertz, how much energy is at 50 hertz, 100 hertz, 1,000 hertz, then you think of these like the window seal that Murray had, or you think of the grommets that Ray was putting up there. And what you realize is that those are just filters in a way, okay? Mm-hmm. So you've got mass on one side of the filter that you're trying to isolate, you've got this material that's going to resist motion differently at different frequencies, right? So if you go look into the spec sheets, I did this for another startup a couple years ago, but if you go look at spec sheets, like at that time we were trying to isolate cameras on a drone. You can actually, they'll actually specify for these things that for so many kilograms of weight or mass, when used properly, these grommets would provide like a 20 dB roll-off, a 20 hertz, 20 dB roll-off. So you can actually go find those roll-off characteristics for these different materials if you look hard enough. Or you can just go find the window seal and kind of work through it that way, right? So that I think that's quite possibly, yeah, I think that's valid. And that could be happening. That could be coupling into that little MEMS IMU BNO 085. But the other thing is what was really remarkable to me, and that is that on my Mecanum wheel robot, because I was concerned, right? You know, it's one thing if you have a tank with tracks slapping rocks as it's barreling down the road 40 miles an hour. It's another thing when you have a Mecanum wheel robot and those wheels are slapping around on the ground. I mean, it's going to put a lot of vibration in. So I was thinking, well, do I have to isolate that IMU? And if I did, how am I going to do that? Because that stupid little IMU is just this tiny little super light card. It's going to have to take some really flexible material to give a good roll-off. Otherwise, anything's going to couple right through mechanically, right? Those high frequency vibrations. So then I did this experiment, whenever that was over the winter, and I had the robot sitting on my Lazy Susan, and I just let it sit there. I didn't move anything, or I just had it set on a table, so it was not moving at all. And I let it sit there for a day. And I did this both in fusion mode with gyro, accelerometer, magnetometer, and I did it with just gyro and accelerometer. Forget the magnetometer, just gyro and accelerometer. I let it sit for a day, and on my little display, the heading, it didn't drift. It was within 0.1 degrees of the same heading over 24 hours. Zero zilto drift, okay? So then came the interesting thing where I put that on the Lazy Susan, and the Lazy Susan has these, it's got a bunch of little ball bearings, so it's going to have some vibration from the ball bearings, but it's pretty smooth compared to Mecanum wheels. So all I would have to do is turn the Lazy Susan a little bit, 20 degrees, put it back to where it was, it's off by a couple degrees. It's off. So what I started to think about, and I mentioned this to David Anderson at one point, we were chatting, but so those fusion sensors, they must, I mean, for it to hold 0.1 degrees drift over a day, right? It's the fusion sensor. So it's taking knowledge, or it can take knowledge of the accelerometer. Accelerometer knows if it's moving translationally, right? So if it's moving translationally, maybe it says, well, that's just it's translating. So I'm going to say that's the normal vibration in the room. So it doesn't seem to be rotating. So I'm going to call this 0 in the gyroscope. But then as soon as you start to move it a little bit, now it has to recalibrate because the gyro is moving. So in the fusion mode, is it going to have to figure out, is that 0? Or is that a bias that I have to take away? So I think that what actually could be going on in our friendly little B&O whatevers is that when you use them in the fusion mode, I think it could very well be partly this mechanical stuff. They call it microphonics coupling through. But I think there's a very strong, because the evidence that I've seen shows that it could very well be the fusion mode auto calibration that takes the 0 bias out. And as soon as you start to give it any kind of even smooth low frequency motion, it's gonna have to recalibrate and it's gonna lose heading.
So how did you solve that in the end?
I'm gonna go with a position reference like optical flow. I mean, because over time, the idea is that's where over time the magnetometer is supposed to help, right? Because if it has some world reference of the Earth that's not moving except for iron perturbances and magnetic fields in the environment, in the long run, that magnetic thing should be able to take it out. So over the long run, I think I'm still a believer in the three sensor fusion mode, because I think that for everything I've seen on the B&O 055, it works pretty well, and unless you get something like a phone and you put it within a few inches of the sensor, that really screws it up. But every other time, it seems to hold pretty well. So
Yeah.
that's my strategy at the moment, is to accept that rather than try and diagnose the firmware and the algorithm inside that thing. I'm going to rely on it. I'm going to accept its little errors. I'm going to try and quantify how it varies under what conditions, right? I haven't done this yet, but I'm going to try and verify, well, if I move it around, at what point, what do I have to do before it actually then recalibrates itself and catches up to zero again? So I'm going to try and understand what it does and then just design around it with other sensors.
Yeah, I think I need to put my tracks back on my hardwood floor. If you guys remember my line of questions about how to securely and how to take the stuff to the floor, well, how to create a line on the floor without wrecking my floor. Anyway, I got to put my lines back on the floor, because when I was previously evaluating the B&O 85, and comparing it to what's built into the Romy, and both were doing reasonably well. That was without a LiDAR spinning on top, but I guess I didn't get that drift that you're describing. I guess I never tried letting it sit for a day, but just doing 20 loops in a small oval that's kind of 3-4 feet wide. As I mentioned again, that dates back a couple of months now. I was ending back where I started with a maybe a 1 degree error, which could be attributed to measuring, because I was lined up to the line, right, as well as my line sensors could make me line up. So I guess, at least absent the LiDAR spinning, the B&O was doing reasonably well for, let's say, just short periods of time. I haven't done a long-term driving test yet. So what I really should be doing is repeat that test, with and without the LiDAR spinning, and then I would know if it presents a problem. Like I said, I haven't done that yet, but I've just heard a couple whispers about vibration and IMUs, which has me a little worried. And so I'll probably do just kind of a common sense amount of mechanical isolation there, because no matter what, I don't want that vibration going in. It's not a lot, but I don't think I want it. So right. I'll do a little bit of isolation, and then we'll see what the IMU says. So maybe I'll have some updates next week. I should really put my lines back on the floor and do some line following, which again, as I mentioned previously, for me I think it's a good way of having an absolute reference, right? And do a couple calibration tests or other tests where I know for sure I'm now back at square one, so to speak. I'm back where I started from, and very much in the exact position and angle that I started from, and that I think is a useful way to evaluate some of these error kind of situations we have to deal with. So I have to do that. I've been wanting to put a longer track, going out the door behind me, down the hallway. So I was planning to do that one of these days, to have a longer reference track where I kind of have much more ground truth available, where I can go follow the line and do it a couple times. And what I've been wanting to do is do that and collect LiDAR data as well, and see how good the LiDAR data is, and how well some of the different SLAM algorithms do, and in knowing exactly where the robots is, compared to what my ground truth is telling me. But yeah, I definitely I'll report back. I'll take the action to report back on how well the B&O 85 does in the presence of vibration. So maybe before I do the isolation with foam or whatnot, maybe I should do a test run to see if there's a
yeah. I think you need to calibrate, and you need to remember the test conditions too, because when you're driving your robot around in the loop, you're giving the B&O the chance to recalibrate itself, because you're collecting data in different orientations. And if you do that in a fast loop that's relatively small, it's gonna give it a different set of input to recalibrate against automatically in the background versus a long loop, right? If you're doing a figure eight, it's one kind of loop that's different from a loop that's only same direction all the time. So
yeah, I'll do one kind of loop. I guess what I was trying to say is I'll do it with the lidar spinning and without the lidar spinning, no mechanical isolation, just to test the theory. Hey, does the small amount of vibration, which I can't really quantify or measure, does it have an impact on the B&O 85? So maybe I'll have an answer to that question next time.
Chris, you also have to remember that just the fact that you have an electrical motor spinning, irrespective of any vibration, may affect the RBNO. I know the servos on my robots affect the IMUs. It's not vibration, it's just the fact that you're generating an electronic field.
Yeah, you're right. I mean, there's other things going on, and it's not like there's zero vibration. There's already some vibration. Okay, I don't have mecanum wheels. I have fairly smooth it's not super soft wheels either. It's a fairly hard rubber, but there's got to be some vibration already that it's experiencing, but not enough to call it vibration, I would say. But with the lidar spinning, there is definitely some subtle constant movement going on that's definitely sort of vibration. And so I'll have to see if that makes a difference or not. Maybe it doesn't. Maybe it's in the end nothing I have to worry about. So I'll find out.
Hey, Chris, those little isolators, they're pretty much made for that. I always remember the guy that, well, I don't know if he made these particular ones, but he had a demonstration, and he had it looked like a golf ball, basically a golf ball. It was except for the color was blue, similar to the color of those isolators. And he would drop it from about, head height or so on a hard surface, and it would not bounce. It was, you'd expect something that looked like a golf ball to, bounce multiple times. And this thing would just go boom and sit there. It didn't even look like it took one hop. It absorbed the energy so well. But kind of again, what Carl said, the formulations of that material, they're going to have certain vibration damping characteristics, and it just may work. They're cheap,
And it depends on the mass too. So I think, Kelly, you raised your hand. Just jump right in.
Okay. Yeah, I've seen these dealt with on 3D printers and drones and rifles as well, where you have something in motion. Any type of beam is going to have a harmonic frequency. So if you need your slam tech on some rubber isolators, but after that, you could actually do some tests and find what frequencies it vibrates at the most or has a harmonic frequency, and avoid those. And there will be inherently quiet frequencies that you could run it at that would be good for your particular isolators. And I'm seeing them even put gyros on 3D printers to find out what the fastest speed they can print at without causing echoes, which are essentially harmonic vibrations that show up in the printed product. So the 3D printer guys, they find a quiet frequency and they print at that speed for the maximum quality at the maximum speed. And so just experiment with frequencies.
Good to know. Thank you.
And Chris, I was only holding up this particular sponge seal because I was using it for a couple things, but it's got a cross section that's actually hollow. I'm not sure if you can see that, but
yeah, I've seen that stuff at the home center.
Yeah, and the nice thing is that if you mount it and then just have whatever, like your PC board or whatever on the other side of that with just a tight, I should say a very loose tie, like maybe, I don't know, nylon wire tie or whatever, just holding it against this stuff without compressing it, it has very, very little I can't imagine what the frequencies. I go with what Kelly's saying as well, because I have a background in sound, and so it'll depend on the harmonic frequencies. But this stuff doesn't seem to transmit hardly anything, because you almost have it's got a round surface. So there's almost nothing touching. And of course, something will come through. But I would think that something that has an internal, it's not a solid foam, but a hollow foam core would probably give you the best isolation.
So Ray, when you were talking about that thing that didn't bounce, was that a magic trick you saw?
Not at all. No, it was just basically a thing that looked like a golf ball, but it literally, he dropped it and it didn't even look like it took one hop. It just went,
There's
straight
a
up.
friend of mine that
straight
passed
down
away a
and
few
got
years ago that made a very, very well-known magic trick, and you can guess what it does by the name of the trick: bounce, no bounce. So you had two balls that were identical. One would bounce and one wouldn't, and he had a whole effect out of it. His name is Jim Nevison. He passed away, I don't know, about 15 years ago now. But he was a fantastic individual, and he worked in that material science kind of thing where you were just talking about. And so he made this whole trick, and people all over the world have bounce, no bounce, and they're still being manufactured today on that kind of thing. That's pretty cool.
Oh yeah.
Let's see. Was something else too. I forgot what it was. I don't know. I'll come back to me. I'll interrupt again. Whatever.
Just so you know, so one last thought on this IMU thing. So as we talk about these dampers, one of the ideas that I've had, and I just haven't had the need or the time to go dig into it yet, but I was thinking that like all these materials we've held up, it looks to me that they might seem pretty good dampers to our fingers, but I could imagine that at higher frequencies that these tiny sensors and the super light masses in these sensors, they might actually still couple quite a lot of energy at the higher frequencies into these sensors.
Oh yeah.
And all those would have to do is then get detected in like AM radio or something, and all of a sudden then they start to those higher frequency noises start to show up in the baseband that we're concerned about for the gyro movement. So one of the thoughts that I had, if we had trouble finding like materials, and Kareem put a link out with some pretty neat ideas in the chat here, but if we can't find materials that don't do a good job of isolating a super light little circuit card with the B&O, I've been wondering, well, why not go mount the B&O to a piece of metal that has some mass to it, and then use some of these somewhat beefier dampers that, the smallest, lightest dampers we can get, but they're still beefy compared to the B&O, but then maybe they're the right size compared to the B&O on top of a piece of metal with inertia or something heavy with inertia. And then that way you can get better mechanical damping.
If you look at how soundproof rooms are done, they actually have to use multiple different layers of different materials in addition to the baffling, because you get bass frequencies and higher frequencies. You actually have to filter on every different frequency, and each of those different materials will have a different, as you say, a different kind of acoustic property, and they have to actually work together to keep everything out. I was going to point out that in the sense that I've been trying to design this Mars rover, I came up with an idea which I'll paste into the chat of using actual isolation, which isn't my idea. I was just noticing that a lot of the bigger, like university rovers, they actually have all that cushioning in the wheels themselves, so that your whole rover sits on a cushion of moving wheel of damped wheels.
Dampers.
Yeah. So you don't have to have shock absorbers. You just actually have it in the wheel itself. But you can't.
I was going to say about the shock absorbers and stuff. We were talking about some other thing just a moment ago. Bruton, I'm sure we all know who he is. He does a bunch of robots that just do crazy stuff. He does a lot of active suspension using load cells and that sort of thing. So where that rubber ball would drop and it would do nothing on there because of the material it is. He's using active suspension so that when you go to the suspension hits the ground, it can react fast enough through some either piezoelectric stuff or some load cells to then usually to actuate stepper motors to counteract that motion, that bouncing motion, and just bring it to a stop real fast. It's pretty cool. But it's he's got some high end stuff that's pretty much made out of at the moment.
The problem with that is that you're dependent upon the response time of your active filter, and that's probably not going to be high frequency.
Most of what he's doing is things like keeping his two-legged robot from falling over to side and that sort of stuff. It's not going to stop the frequency stuff from, let's say, a fan motor from messing around with putting in extra noise to other vibrations and stuff like that.
And part of the problem with any of these solutions is that not all, but most of our robots are pretty small. So the idea of having an active suspension system or anything like that, I wouldn't have room for that on the tiny robot.
He makes some pretty sizable things when he throws them together. Pretty sizable things.
I did one question to Carl, because I'm also using the BNO55, and how did you manage in the end to keep it from losing calibration? Because that was I was seeing nice calibration when it happened, and it would hold, within a certain number of degrees. But if I started running my robot around, it would often just lose calibration after a minute or so. It just out of calibration entirely.
I wouldn't say that I've solved that yet. See you, Jack. I would say that what I've noticed is, so on mine, I have the lights that show real time immediately when it loses and which one it loses. So I can tell with 3 lights what's going on, if it has full fusion and if any one of the 3 drop out. So I can tell which one. But so when that happens, I'll just tilt the robot over one way or the other for a moment or two, and then it seems to gain calibration again.
Yeah.
But what I also do, and I don't know if you do or not, but I went to the trouble when I first attached it back in February, January, of storing calibration values in EEPROM. And I wonder, and when I did it, it was a really reckless, careless routine that I went through. I'd done it pretty accurately before on this one drone project where you sit it you get a very square cube kind of a block, and you hold it for X amount of time in one dimension, and you hold it on each of the 6 faces for a long period of time. And that was what it took to get a really quality calibration for that particular IMU. Whereas on this one that I've been playing with, I just held it by hand on my lap, and that's the calibration I've been using for 6 months, and it seems to do pretty good. So what I'm thinking is, why not try that again, but with a much more careful calibration. And then I also think that there's another approach of, I could swear I've seen even some people that have the IMU, the B&Os mounted on a pivot table of some kind, so that every so often they can swing them up in the other dimensions to give it. So they'll sit the robot still, swing it up, and then just help it recalibrate.
Yeah, I think I remember now that you had mentioned something about actually writing to the EEPROM, which I haven't done. No, I don't really want to add a servo thing on the top of my robot.
Yeah, and that adds other things too, right? Because then does it get back to the same place every time? It's as bad as the dampers. If the dampers are really good dampers, then the thing's going to shift around on you. So
I might try the EEPROM thing. That's not a bad idea. As you said, it's kind of it's a bit of trouble to go through rather than just shaking a robot in the air. But if you're actually around other people, if I went and took my robot to the park, I can't imagine shaking it in the air and feeling like good about myself after that.
Not every time it boots up, and I noticed that when I first did it.
Do it when they're not looking.
When I first tried it before, I would have to move it around a lot every time I powered it up, and I thought that was for the birds. And after the EEPROM stored even my cheesy hold it in the lap calibration, it powers up calibrated most of the time and holds it pretty well much of the time.
Okay, I'll give that a try then, because that's been my only beef with the BNO55, because otherwise I really like it. It's quite reliable. I've not been so lucky with the 85. In fact, I've had all sorts of troubles with that one, but the 55 has been really good.
I think Adafruit has some libraries that make it convenient to, or if not, I can share mine with you if you want
make it 85
to do that.
For the 85?
Oh, for the 55.
Oh no, the 55 I'm fine. I've got.
Yeah, okay.
Yeah, thanks.
Yeah, if you're using any of the Arduino libraries, I looked at the version that I had. It was very old. I was like, wow, they've made quite a few, updates to it for both the 55 and 85. So maybe it pays to check your, library, whether it needs installing or updating, and before you do anything with it. Hopefully she's making improvements and not going backwards,
There's a lot of secret sauce in that thing.
Mm-hmm.
He goes, well, I have to step away for a little bit, but if someone wants to jump in and find another topic to chat about, then just keep it going, and I'll be back when I can, okay? Now, somebody here has something to say. What's it going to be?
A couple weeks back, I had sent out my robot chassis dynamometer description, and I've been out the last couple of weeks, and so if anybody had any questions on that or comments, I'm glad to talk about it.
Oh, thank you, Dave. I actually was, I think, probably one of the people who'd asked for that. I looked at that, and I unfortunately don't have, I'm not sure how the math is not so hard now that you've described it. The only part I would have trouble with is I don't have a machine shop, so I wouldn't know how to make those heavy cylinders. I guess you could make them out of anything like a can and fill them with, I don't know, epoxy resin or something like that. But how would you get a balanced metal object without having a lathe?
I'm not quite sure, since I have a lathe that's not an issue.
It looked like a lathe project, yes.
Yeah, I happen to have a couple chunks there that a friend of mine had melted down some aluminum and poured them into a can, and then I drilled a hole through it and turned it.
Yeah, that's nothing I'm going to do in my basement. So
Very
I don't have a lot of
with
molten
the
aluminum
lathe.
in my basement.
Murray, you had the wrong question. The question is, how do I get a lathe?
That's right.
Well, first of all, you got to go talk to the girl first. See? Oh, how to get laid. Sorry about that. Sorry, I misunderstood.
He'll be here all night, folks.
So I have
You're
an
thinking
observation.
of the more enjoyable stuff.
So I have an observation. I've been beating my head against the wall this last week trying to get my telepresence robot to work, because it's the first time I've used a continuous rotation servos. And so I would try to tweak them a little bit and make it go straight. And then I'd run a test again and nothing would happen. And I'd tweak some stuff and it'd start working again. And I was having a lot of trouble with that. And, I found out that the old maxim, which I had forgotten, is that most of the problems with these things are wiring problems, turned out to be true. Because I eventually got to the point where I was tracing down my wires and I just squeezed one of the connectors. And as I squeezed it, it worked. If I let go, it didn't. So clearly my solder skills are not up to speed. So hopefully I'll have more information next week. But for this week, all I've got is solder properly and test properly.
Yeah, I've wasted a lot of time trying to track down what was wrong with my software, only to find out that one of the connections was fritzed.
Yeah, I keep threatening to get better with this thing. Multimeter. But check if the connection goes through or something. But
Yeah.
It's not the first thing I pick up to test things with.
No, unfortunately, it's usually the last thing I try.
Right. I'm a software guy, not a hardware guy. So I usually blow up or mess up my hardware and keep trying to find a solution in the software until I eventually get back to the hardware.
Yep. Connectors and switches, the least two reliable components in any, electronic circuit, unfortunately.
Yeah.
Hey, is Kareem on? Kareem, are you
Yeah, I'm
there?
here.
Hey,
I'm here.
I had a question about the Rev robotics controllers. Are they similar to the Ion Motion ones, where you can do like a pretty much a whole motion profile, like you can specify speed, acceleration, deceleration, even position for each motor. Is that how that one's set?
You're talking about the Spark Max? I think you're talking about the Spark Max motor controller. Yeah. So they got different kinds of controllers. So there's like a higher level robot controller, and that runs the Android operating system. But they also have brushless motor controllers. And I think what you're talking about sounds more like the Spark Max brushless motor controller. And yes, it does support motion profiles. You have to talk to it over CAN bus to get the full feature set.
Yes, the iMotion ones are just through Gyro UART.
Yeah, they don't have UART support on those. Is it me or is it Ray that's breaking up?
It's me.
I think it's Ray.
Can you hear me?
Every once in a while?
It just says it lost internet connection. Can you hear me?
You need some Starlink.
Try to read.
Have you turned it off and on again? Anyhow, if he's still listening, I don't have a lot of experience with the their brushless motor controller, but we actually plan on using it this summer. I'm also looking at the O-Drive motor controller. I think we lost him. Anybody else?
I would like to whine about I2C.
What about it?
Okay, go for it.
I'm trying to get my all the stuff working on my my ExoMi, my rover, and I got a tiny LiDAR, and I check it out and I get lots of good information of it. All the ROS connections, ROS nodes want to talk directly to the BL53L0X chip to do things. The tiny LiDAR is got a microcontroller on it that helps you do things. So same sorts of commands and things, but it helps you do things to get information and things off of them. It's pre-calibrated, just recalibration and some other stuff for you. And I'm like, okay, maybe I'll write my own. That's fine. I think I got a pretty good handle on how to do this. But then the tiny LiDAR stops showing up on my I2C bus. I go from the Raspberry Pi to the tiny LiDAR to the IMU. And when I'm doing the I2C detect, I saw them all for a long time. And at some point, for some reason, it could be wiring, but I think I've eliminated part of that at the very least, because I'm like, okay, when I put this in there, I don't see anything. I don't see the two things I'm caring about, the IMU and the tiny LiDAR. And so I started pulling things apart and pushing things together. And when I just have the IMU on by itself, it works as expected. Funny thing is that when I'm tracking all it's sitting still on my desktop. You guys were talking about vibrations and stuff. I've got a big air conditioning going on and some other junk in here. It'll be setting what to the human eye appears to be still on my desktop, and the numbers in the second and third decimal point sit there and just twitch like crazy. So it's not really as still as I think it is. So I'm like, okay, that's good. I'm getting good data. I'm getting stuff into the ROS system, into the bus, so I can talk to that. I can listen to that topic
going forward. And so now let's get the tiny LiDAR going. And in the way it's set up, the tiny LiDAR, when I ask it for a measurement, there's a couple different ways to do it, but it'll give me back a thing in millimeters. And I'm like, okay, I'm just got a range, I get a number. I go, hey, give me your, what do you got? Got it. And I can write a ROS node to spit out the range. Pretty easy. In fact, there's a message already built up to do called range that will take a distance and a bunch of other junk that I don't care about right now. But when I plug these all together, now I stop getting, I was at one time seeing both of them on the bus, and they stopped seeing them. So I think something went horribly wrong somewhere. But if I pull the tiny LiDAR off, attach it to an Arduino, it comes right up. So I thought, well, maybe pull-up resistors, because there's pull-up resistors on the tiny LiDAR that's not normally on all those boards. And I know that can cause a problem that's going on. So I cut the traces because they give you a place to cut them. I did that. And even though it doesn't show up on the I2C detect, if I run the Python test script that I found online, it gives me back numbers in the spec. So it just is really, really weird. And so what I'm to the point is now I need to get my GPS into the ROS world. I'm reading stuff off the UART, but I need to get that into a ROS message on the message bus. And so when I get back on this tomorrow night, we'll be dealing with GPS node, and I'm hoping that that's going to limit my robot and able to do some stuff on the cone. But I'm hoping with some of my cognitive services and image recognition and stuff, maybe I can get close enough to grab a couple of points on the demo.
Hey, Harold.
On the trial.
Harold, are you chaining your I2C devices, or are they all getting connected directly to the Pi?
Chaining.
Ah. Try connecting directly to the Pi and see if that makes a difference.
I will when I do it with IMU. That's one of the first things I charged because it was easy enough to do with the IMU. Boom, I've got it plugged in there. Now, what the problem is, I'm running out of pins to plug into the Pi on my I2C bus, right? So there might be a way to get around that, and I'm sure there are, but I just don't have those parts. I didn't have those parts handy. You know,
well, if you're chaining, what's the actual ultimate length of the last item in the chain in terms of inches?
In terms of inches, hold on, let me look here.
Because you can't go very far with I2C, just a very short distance.
I got 6, probably 12 to 18 inches, maybe.
You've exceeded the length then. You really can only go maybe 10 or 12 inches max before you start running into problems with reliability. And if you're chaining it, maybe even interacting with the other sensor, I don't know.
Yeah, okay. Well, I'll see if I can handle that. I know I can live without the LiDAR for a little bit because I've got some image stuff and it gets me close. But I know I can't live without the IMU because I need to know at least some semblance of orientation so I can know I'm pointed in the right direction or close to the right direction when I start moving.
Well, one of the things I found on my robot is that the Pi is in the back of the robot, and I've got one of these little breakout garden things with the sockets on the front. And these actually kind of act like an amplifier in the sense that they've got a 5-volt power supply to them. And you can plug things in here and get like an extra 8 inches or extra 12 inches or 10 inches or whatever that maximum length is.
I was looking at that Pomerone garden thing you were holding up. That's a nice setup, man.
I've got. They make them in 3 and 6, and then they also make them with an SPI in the middle as opposed to 3 I2Cs. And I've got a socket of 6 in the back of the robot and a socket of 3 in the front. And like I said, the one in the front, because it's powered, you get an extra, in my case, maybe 10 inches. So I can even connect more in the front with more length.
So maybe that's what they did. Well, what's funny is that if I put the tiny LiDAR into play here with basically the same length of going between it, it doesn't show up on an I2C detect, but I can see it in their test program they've given and stuff, which is really, really weird.
Well, that just means it's not reliable.
Yeah.
But you sure you didn't make it worse by removing the pull-ups? You sure you still have enough pull-ups in there? And
Yeah,
you were worried about too much pull-up, but you sure you
yeah.
didn't eliminate the pull-up?
In fact, there's a lot of things online that indicate that if you're going to plug this tiny LiDAR into a Raspberry Pi, they recommend you cut the pull-ups. That's what they recommend. And again, this tiny LiDAR, I can show you on the screen, but look it up. But it's the laser chip itself is tiny compared to the microcontroller attached to it, to making this supposedly easy to use, right? So I don't know about this easy to use thing. I'm having second thoughts about all that. So.
And you're saying it works reliably when you connect it to an Arduino?
When I connect to an Arduino, it just spools right up like crazy. In fact, I was doing some tests. Like, I've got some measurements here. I stand a ruler up. I know I've got about 160 millimeters on that. I put it about there. Of course, my human hand bob is not as accurate as it probably needs to be. And that right there reads right about 160 when I want it to be 160.
And when you connect it to an Arduino, is it a 5-volt Arduino? Or you're running it off a different?
I'm running on a Metro, and I'm doing a 5-volt. I'm doing 5 volts on that.
Okay, so when you're going to the Pi, you're running it. You're giving it only 3.3 volts. Is it?
GPIO and those things are 3.3 volts, but I'm powering it with a 5-volt source for the rest of the thing. So maybe there's some issues there too.
So you're powering the LiDAR with 5 volts because that's what it needs.
Yeah.
And it's saying it'll do 3.3 on the I/O.
Yeah, it's got a voltage regulator built onto the breakout board that takes the 5 and reduces it down to 2.8 or whatever the thing it needs, or the base level that what it needs.
And I don't know, you must have Googled this already. I mean, again, the Pi, sometimes it's just not that good at I2C. I mean, it's got some quirks.
Yeah, I found something about some whining about I2C stretching.
Clock stretching, yeah, which
clock stretching, yeah.
It's gotten better on the Pi 4, although it's still a bit unclear.
Yeah, the Pi just doesn't do that, and so
yeah, exactly. There are some corner cases. There are some corner cases that it can't handle, but unless you go down on logic analyzer, you don't know what's really the problem.
I haven't went so far as to install a different Pi, a different I2C driver recommended by one of these things I found online that's supposed to handle that or handle that better, and there's no difference. So I mean, I'm whining about that, but I'm going to let this not die on a vine, but I'm going to let this go and continue on, because I would like to have a robot to at least get, go somewhere other than me pointing it at something and telling it to go forward.
So on the Arduino, you're using whatever library, an Arduino library, but on the Pi, you're using something completely different in terms of software, right? I mean, you're using a different library.
Yeah, different library.
Node.
I mean, literally on the Arduino, it's a half a dozen lines of code to do all the reading and everything, and it's just the I2C library that comes packed in with the standard Arduino stuff.
So, but there must be a library for that LiDAR sensor, right? Or is it literally just you send it a command and you read it back?
It's literally I send a hex code, an ASCII code 68, which is a capital letter D for distance, to an address.
Okay.
And it sends me back a number.
Okay, so it's not like very complicated to interact with that device, not like interacting with a B&O device where you got to initialize it, you got to set up the registers, none of that. Okay.
You don't have to do any of that with this.
You just send it a byte and you get back a result. Okay.
I send it. I say
you can't really mess that up. So whichever way that's done on the Pi in ROS, I mean, you can't really, whatever code is doing that can't really mess it up.
You can't really mess that up either. I got just, I send it a thing, it comes back, right? That's some base level stuff, right? And so I got a little frustrated with that, but I mean, I'm going to let that die for a second, let that pause as so I don't, throw things and destroy things and all that.
Just one more thought. If did I hear you say when you only have that device connected to the Pi, is it working in that case?
It works, but it doesn't show up. You know how you can scan the I2C bus and you can see it does not show up there. However, when I run their test program, I get data.
Yeah,
Whatever,
that's a little bit suspicious.
Yeah. That's
Again,
weird.
I mean, the whole business about cutting the pull-ups, I don't know. Maybe you need more pull-up power. But yeah. Does it have a reset signal, that lighter, or just power ground I2C?
It just power ground I2C. It's got a button, a very slim button on it where I can press it to hit the reset button on that. I did
Yeah, because what I found, even with some of my devices, like the BNO85, and they're all more complicated devices. They all have a reset input. I found, and they've mentioned that before, that it's good to take advantage of it. That I find myself as part of just initializing things. Okay, I gotta go in, explicitly reset that device before I start talking to it. Otherwise, there's a 10% chance that it didn't reset properly, and I can't reach it on the I2C bus. So that's why I'm asking if it has a reset signal.
Yeah.
If it did, I would say use it.
Well, let me show you kind of what I've got going on here, right? So make sure. So this is the tiny LiDAR, and there's a button right there that I can reset. And if you look, let me see if I can get it. Come on, focus up. Thank you.
Yeah, I can see the micro and yeah, I know what you mean.
Yeah, and that little bitty rectangular thing, like that's the sensor.
Right.
That square thing is the actual microcontroller that's
Right.
to make it easy for me. And if I get one of these breakout boards that doesn't have all the fancy stuff on it, they have an X shut, which is basically a reset line, and a few other things, just like you were talking about. And which I may order one of those things up because all the ROS nodes want to talk to a straight up chip and not want to go through my simplified way of doing things. So, for $10, I can get a pair of them from Amazon here in a few days. So I may go that way in a little bit, but I'm going to let that go for a second and try to get the GPS online. So at the very least, the thing can navigate from point A to point B, or at least attempt to. And then we'll worry about how close we get to the cone.
Okay.
So kind of running
So this one is from Robot Shop or similar places.
Yeah, it was a Kickstarter, and I found out, if I want to cuss Carl, I'll cuss Carl a little bit. But I found out about this through Carl and his tiny LiDAR. Hey, Carl's naked. He's not wearing his strappy strap. What's the matter? We got to get on you. We don't want you.
Well, I was doing exercises downstairs and trying to help Ray get back on, because there's only one of us that can let people in the meeting right now. Unfortunately, it's me.
So anyway, I was about to cuss you a little bit. Not really.
Do it.
Because I was messing with the tiny LiDAR, and I'm having trouble seeing it and the IMU at the same time, and it's acting a bit weird.
Oh no!
And when I plugged it into an Arduino, though, it's rock solid, man. If I need it down to the millimeter, within 30 millimeters up to about 2 meters, that thing's pretty good.
Oh, cool.
As I've said, it's just working on. That's on an Arduino-based system. On the Raspberry Pi, doing to some of the things that I found out, the Raspberry Pi I2C is not as up to spec as people want to be, with something called clock stretching. And I went and looked to see what that was, and I go, oh, okay, I got that. And it's not up as par as it should be. And between all those little things, I think it's causing me problems. So
I found the guys that did that tiny LiDAR is really responsive.
Yeah.
So it may be that if you reach out to them and describe your problem, they might be able to help you. And for a while there, they were they had me send a bunch of because I bought, or they'd given us some for the club to give out as prizes. And they had me mail them back to them, and they reflashed them with newer firmware even. So worth reaching out to ask.
And Harold, do you have like a way of testing it outside of ROS, just a straight up, as simple as possible test program, Python, whatever,
I haven't fired up. I have ROS running in a Docker container. The way I've been testing this stuff straight up, I don't have the Docker container fired up, nothing. I boot up my Raspberry Pi and I run a couple of Python scripts to test the thing.
Okay.
And I also use the I2C Detect, the standard I2C tools that you would get if you install a Raspbian. Apt-get install I2C-tools, that sort of thing.
Yeah, if it doesn't show up on that's already highly suspicious.
It is really weird.
It's just a little weird right there.
It's a really weird thing, and I'm like, I don't know what that is. And at one point, I was suspecting my crappy JST crimping skills, because they're definitely crappy. And in this case, I'm using their pre-crimped Grove plug-in, and along with their pre-crimped male ends on the other side that I'm plugging into this stuff. None of my work is even in play.
But Harold, if the total length of your I2C device from the Pi to the device is like 16 inches, you're
Something
way up. You're at least 8 inches past where you probably should be. 6 inches anyway.
Okay.
I thought it was a meter that's allowed at least at 100 kilobits. So, but
yeah, we're running at 100 kilohertz. So, we're not driving it the 400 way. I'm not driving it hard. I'm driving at the base level that most things supposedly run at.
I'm only going on personal experience. I know the specs say they can go further, but I've seen like about a foot is as far as I've been able to get them from Pi.
I got you.
Like after a foot, they still connect sometimes, and it's sort of like Harold's getting this intermittent. Yes, it's there. Maybe it's not there, but he's going through a chain, and that could be it, the chain itself. But it could be just the length, I think.
I'm suspecting that the chain and the extra circuitry there might be just enough of out of tolerant for making things go south.
Well, it should be easy to test that, right? Hypothesis by really connecting it close to the Pi. Make sure you got solid connections, and then at least you can see if it's the way you're connecting it as a problem, or the Pi is a problem.
Yeah, I can do some of that.
Isn't that bus? Is that one of the buses that needs a special termination resistance too, or pull-up resistors? I'm thinking the other SBI.
No, it's I2C. You're correct, but the pull-ups are built into the Pi, and that's why he removed some pull-ups from the device. But, having extra pull-ups, probably doesn't hurt.
At some point, there's too much pull-up, right?
So at some point, yes, that's true. That's true.
Yeah,
that's
One
true, but
question
it's not that sensitive.
LiDAR. Is the tiny? I mean, I've been using this little Pimoroni one with the VL. What is it called? The VL53L1X. Is the tiny LiDAR essentially any different than this?
No.
Oh, okay.
It's well, yes and no. The tiny LiDAR has the older chip, the 0X versus the 1X. That, as near as I can tell, the only real difference is maximum, the range maximum is how far more it can go. It's near as I can tell. And then what else it has on it is it has a little microcontroller to help deal with the VL whatever chip directly. And all you're doing is literally sending, hey, I want a distance, ping a distance, and it gives you back a number. And all the other firmware and all the other stuff on there that does the calculations, the time of flight stuff, all that noise is on the microcontroller itself.
Oh, okay, because the one I'm using, the Pimoroni one, has a Python library that gives me a distance measurement, and not just a number, but an actual measurement in distance. So they're doing it for me in software, I guess.
They're probably doing it in software. Yep, inside that library. And you
Right,
probably got an X shut pin on there, as well as the I2C pins, and you might have one other thing on there as well.
No, it's actually really simple as a device. The library is really dead simple.
Yeah, it is. Yeah.
Okay, thank you.
Yeah.
Yeah, I guess one of the things that this tiny LiDAR does, that's why they need the big microcontroller. I'm reading on the page that do ultrasonic, HCSR04 emulation, so you can wire it up and pretend it's a ping sensor, ultrasonic sensor, and if you have set up and code that wants to talk to one of those, you can just pretend you have one of those.
You can pretend you have one.
So that's what the microcontroller does, I guess. Apart from other things.
it does give you some extra capabilities in the whole thing. And the one reason I bought this was because I saw Carl give a thing on it a couple of years ago, and I'm like, dude, I got to use that. So I'm going to use that now. And so,
Yeah, I think I might look at. I mean, I didn't realize it has this ultrasonic emulation. That's pretty cool, actually.
there's a lot of cool things with it. There's a lot of cool things with it.
All right, thank you.
Yeah. So I may revert just a little bit to an older, to a not so sophisticated breakout board that just has the VL53 on it, and then I have to have a library to give me the.
Also, I'm just reading because to my earlier comment about if you have a reset input, use it. They're saying they have a hardware watchdog timer, and if they don't see any I2C activity in 3 seconds, that watchdog timer is going to take care of resetting
itself.
the unit. So if you don't talk to it for 3 seconds, according to what I'm reading here in the summary, it'll do a reset on its own. But it's good to know, I guess. It's interesting.
Yeah. So I got some more planned to do that. One of the biggest problems is, like I talked to last week, and Murray gave me some ideas of some tools and things to watch the I2C bus and the SPI bus and that kind of thing. Is I currently don't really have any good way to. I do have a Saley something another logic analyzer here that I've never gotten to work very well. But really, what I think my problem would be is I would like some kind of O-scope so I can get to the waveform to make sure that I'm indeed seeing what I think I'm seeing, as opposed to just a logic 1 and a 0 and with that a logic analyzer give me versus what I can see the actual waveform. And I don't have any of that at the house at all. Working on it. We're coming, but not yet. I think you're muted, Mary Murray.
Yeah, I was just gonna say my birthday's coming up, and I keep thinking about buying something for myself, and it would be like I've got this big old Iwatsu Japanese oscilloscope, and I wouldn't mind replacing it with like one of those little, I can't remember what brand is, but they just have the input device and you hook it up to your computer, and those are nice.
Yeah, the Handtech guys do a nice one of those, I think.
Yeah, and that way I can get rid of this big, giant, huge box that to actually put it on my desk, I have to move a bunch of stuff out of the way. Although it is cool looking. I mean, anyone who sees my oscilloscope is thrilled. Well,
oh, I had no doubt. Have you? There's a cat on YouTube called Smarter Every Day, and if you look back over the last year or so, he went and visited some cats over in Germany. That if you've got an analog, the digitals don't do this so well, but if you've got an analog scope, that they make music that draws pictures on your scope, and I'm not talking about I'm just drawing a box or a circle. No, these are like they put like whole shows on your scope. It's amazing, man. It's
yeah. I've seen a 3-dimensional rabbit done on a scope that you could rotate.
Mm-hmm. They're doing things like that, and it is really pretty cool. Most god awful music you ever heard, but the picture comes out looking great.
All right, who have we not heard from yet? Enough from me.
Jim's online. Wow, cool, Jim. He sent me some things. Let's go look, see what he sent me.
Is it crickets, I guess? I think that sounds like we might have hit the end of the road.
Maybe.
I'm fine with that. It's time for me to go anyway, but you guys keep going.
We call it an early night.
Yeah, I think so. Have a good week, all.
All right.
See you guys next time.
All right. Take care, folks.
Carl, are you there? Anybody there?
Write stuff down, and I wouldn't have known that was the way it was spelled.